In this lecture, we'll talk about Cramer rule. So let's just get to our topic. Consider the system of equations of the type a1x plus b1y c1z equal to d1, a2x plus b2y plus c2z equal to d2, and a3x plus b3y c3z is equal to d3. Then by using Cramer rule, we would have x is equal to determinant over determinant. Similarly, for y and z, the process is the same, where determinant of a should not be equal to 0, where a, of course, is the matrix. Now, this is just the definition or the way to represent the Cramer rule. In order to understand it in a better way, let us move on to an example. So we have 3x1 plus 4x2 minus 3x3 equal to 5, 3x1 minus 2x2 plus 4x3 equal to 7, and 3x1 plus 2x2 minus x3 equal to 3. So we have a system of equations. We have written it in the form of a matrix where we have A, X, and B. B is the numbers on the right side of the equality, while the matrix A is the actual system of equations that we have to solve, and X are the unknown. So by Cramer rule, if we have to solve this equation, we'll have to find x1 equal to determinant ax1 over a. Now the main point is that this particular part shouldn't be 0. If this is 0, we cannot solve this equation. So the first step in order to solve an equation with the help of a Cramer rule is to find the determinant of the matrix. So we have the matrix 3, 4, minus 3, 3, minus 2, 4, 3, 2, minus 1. Its determinant after solving would be 6. You can find the determinant with the help of the methods discussed earlier. So, as the determinant of A is 6, that is not equal to 0, so we can move on with our equation. Now, the next step is that we'll write the determinant, that is 6. Now, here is an interesting thing. In the Cramer rule, you have to substitute the first, second, or third column with the constant column depending upon the type of variable you are trying to find. For example, this B573 would be replaced by the first column, that is 333, while the remaining columns will remain the same. For x2, this column would be substituted with this one, while the remaining would remain the same. I hope now you have understood the concept. Now we'll replace it with the first one. So we'll write 5, 7, 3 instead of 3, 3, and 3. So the remaining will remain the same. 4 minus 2, 2, minus 3, 4, and minus 1. Similarly, for x2, we would have 3, 3, 3, 5, 7, 3, minus 3, 4, minus 1 over 6. For x3, we have 3, 3, 3, 4, minus 2, 2, and then 5, 7, 3 divided by 6. Now you can solve this question further and find out what the values of x1, x2, and x3 are. That sums up our topic for today.